Hello everyone, my name is Emma Kate Mask and today I'm going to be sharing an activity for teaching Euclid's fifth axiom while addressing the Mississippi College and Career Standard GCO1. So a little bit about GCO1 is that this standard focuses on students knowing precise definitions of terms such as angle, circles, perpendicular lines, parallel lines, and line segments. Those definitions rely heavily on the undefined ideas of point, line, and distance. This standard is all about knowing accuracy and precision, making sure that students know how to communicate clearly in geometry. And the one that we're going to hone in directly is parallel lines. So, according to the standard, students should know how angles are formed and measured, how to construct angles and lines, and how to name geometric figures correctly. They should also be able to understand that when we talk about geometry, our definitions need to be consistent and specific. And finally, they should be able to recognize correct examples and non-examples of geometric figures, use proper symbols, and attend to precision. So this directly ties into what we studied back in week 4 about parallel lines. We looked at Euclid's fifth axiom, which says that if the interior angles on the same side of a transversal add up to less than 180 degrees, then the lines will meet, as displayed in the drawing, where we constructed line 1 and line 2 and made a transversal T. And if you extend those lines, as drawn in the red lines, they will intersect at some point. The blue lines show that they are less than 180 degrees. And we also discussed the modern version of the Playfair postulate, that there is exactly one parallel line through a point, and we reviewed the angle pairs, which are alternate interior, corresponding, supplementary, and use these in Euclidean proofs. All of this relies on precise definitions, which connects the course content back to the GCO1 standard. So for my classroom activity, I decided I wanted to do something simple, visual, and hands-on. So what I wanted to use was uncooked spaghetti noodles that will model lines and a transversal. So what the students will do is they will physically create the lines, then they will identify the angles, and then they will measure them using their protractor and explore how the angle sum predicts whether the lines will meet or stay parallel. This will let them experience Euclid's fifth postulate instead of just reading it on paper. So next, what we're going to do is see it in action. So here's how the activity will work. First, the students will place 2 noodles on their desk to represent the lines, and then they'll label the endpoints as shown below. They'll do perhaps A, perhaps B. They'll label where they intersect at C, and then they will also label the other areas as A prime and B prime as part of the line segments. Then what they'll do is they'll add the third noodle as a transversal. We can call this transversal T, and then they'll identify the interior angles on one side of the transversal, particularly the inside part, and then the interior, and then they'll measure that with the protractor. And so as seen below, this is an example of me demonstrating that, hey, I am measuring the angle of this interior angle, and then they will record the sum. And so when they record the sum, they can call each angle perhaps alpha and beta. Then with this, they will gently slide one of the noodles to create a new diagram and measure again. They can try this as many times as possible to get different answers. Each time, they'll notice if the angle sum is less than 180 degrees and if the lines will eventually meet. I will ask some questions such as, how does this connect to the definition of parallel lines? And also ask them, what do they notice about the interior angle sums? And so, for this example, I would show them, and they would have an example similar to this, ask them on the inside part of the transversal, what do they notice about the angle sums? And perhaps I may say, when the sum is less than 180, what happens to these lines? So after the hands-on exploration, I asked the students to show the official statement of Euclid's fifth axiom and connect it to their observations about the postulate. This then will lead them to the realization that they essentially have discovered it all on their own. And so, how does this align to the standards? We'll see on the next clip. So this activity directly aligns with the GCO1 because students are using precise definitions, measure and construct angles using notation, and identify examples and non-examples. It also supports the mathematical practice of attending to precision. So, in closing, this activity helps students experience geometry in a way that feels meaningful and engaging. It brings Euclid's fifth axiom to life and supports the foundation students need for reasoning, proof, and understanding parallel lines. It also reflects the type of student-centered classroom I hope to create.